Hi, my name is Fatin Syuhada, BINTI HARDON, and my matrix number is B20EA0093. I'm from Group 80 from Pang and Associate Consulting. And I will do my major presentation for Erosion and Sedimentation Control Plant Design Department. First, for introduction, erosion and sedimentation are natural processes that loosen and move soil due to wind, water, or ice. Key construction procedure can hasten erosion and sedimentation where soil surface are exposed and not initially revegetated. And this process, if left unchecked, can result in poor water quality, land degradation, and loss of aquatic habitat. And lastly, BPM, which means best management practice, can prevent erosion and sedimentation. Okay, for the site description, our project is located near Persiaran Datuk Jelan, Mukim Tebrau, Johor Bahru, Johor Darul Ta'zim, and it is covered with hills, Sungai Pulai, housing area, and Tasik Biru and Plum Oil Plantation. Okay, this figure shows satellite view of project site. Okay, the proposed project of developing a residential area need to undergo erosion and sedimentation plan to design and avoid problem after the construction phase. And figure below show our final proposal of design ESCP in the site area. Okay, next is for the runoff management. The primary purpose of temporary BMPs such as erosion, runoff, and sediment control BMPs is to reduce erosion and soil transport away from the development or construction site. Okay, next is BMPs are required for all land development and infrastructure project no matter how little or large. Okay, next is design criteria. Okay, first rainfall estimation, which we have average recurrence interval or we call as ARI. Next is time concentration, and lastly is average rainfall intensity. Okay, for the peak discharge estimation, it is a rational method, and the peak flow occurs when the entire catchment area is contributed to the flow. The rainfall intensity is uniform over the entire catchment area, and lastly, the rainfall intensity is uniform over time duration to the time of concentration. Okay, from the calculation that we calculate is we get total area equal to 45.801 hectare for the T0, which is overland sheet flow travel time, we get 11.511 minutes. And for the drain flow travel time, we get 23.390 minutes. For the time of concentration, we got 34.901 minutes. And for the average rainfall intensity, we got 117.922 millimeter per hour. And lastly, for the peak flow times area, we get 2.35 meter cube per second. Okay, next is temporary drainage. Okay, the channel may be easily designed due to the simple formula and parameters for the optimal hydraulic section, and the ratio of the surface width to the depth and the bottom width to the depth remain constant. Okay, next is temporary drainage system is used to redirect or channel runoff to a speed trap, decreasing the runoff. Okay, the design of our project is referring to the best hydraulic section, which called BHS, of trapezoidal shape open channel because this design can produce large outflow. Okay, next is for the calculation design drainage, we use Manning formula, which is Q flow rate of discharge equal to cross-section area times by hydraulic radius, power of 2/3 times by channel bed slope and divided by y. And from this calculation, we get ratio of D1. We get 0.527. And for the QD1, we get 1.1817 meter cube per second. Okay, from the calculation that we made, Q equal to AB, which means equal to 1.109 times 1.942 and equal to 2.153 meter cube per second, which is larger than QD1, which is equal to 1.817 meter cube per second. And this shows that our design is okay. Okay, next is concentration time. Okay, from this table, we can see that we have catchment area 1, 2, and 3. For the concentration time, catchment area 1, we get 34.282. For the catchment area 2, we get 26.086. And lastly, for the catchment area 3, we get 37.242. Okay, next is average rainfall intensity, or we call it ARI equal to 10 years. From this table, we get we get average rainfall intensity for the catchment area 1 is 119.066. For the catchment area 2, we get is 137.429. And lastly, for the catchment area 3, we get 113.828. Okay, next is temporary drainage design. From this table that we calculate, QM that we get is D1. For the D1 is 2.153. For the T2 we get 1.203. For the D3 we get 1.664. For the D4 we get 2.854. And lastly for the D5 we get 2.751. Okay, next is sediment control BMPs. Okay, sediment control BMPs are often positioned on the lowest side ground. Okay, for the sediment control are often eaten to temporary remedies. Okay, lastly, BMPs carefully built to guarantee that the facilities offered can meet on-site demand. Okay, from this calculation that we shown, the value that we get are rainfall erosivity, which are factor equal to 15,000. Okay, next is K, we get 0.026, and lastly, LS factor, we get is 5.598. Okay, next we continue. From this calculation show, we determine C factor equal to 0.2, and then next we determine P factor equal to 1, and then soil estimation equal to 432.406 meters square. Okay, for the result of soil estimation, existing condition area that we get from the catchment area 1 are 432.406. For the catchment area 2, we get 24.720. For the catchment area 3, we get 164.062. Okay, for the earthwork, which we get uncontrollable condition, the area for the catchment area 1 is 2,932.655. For the catchment area 2, we get 167.653. And lastly, for the catchment area T3, we get 1,112.697. Okay, lastly, for the earthwork, which is controllable condition, the area that we get for the catchment area 1 is 1,164.062. For the catchment area 2, we get 66.547. And lastly, for the catchment area 3, we get 389.647. Okay, next is sediment yield estimation. The amount of sediment per unit area removed from a watershed by flowing water during a specific period. And lastly, modified universal soil loss estimation, or we call it MUSLE. Okay, from this sediment yield calculation, we get for the peak discharge equal to 3.451 meter cube per second. For the runoff volume, we get 7,098.587 meter cube. And for the sediment yield estimation, for the catchment area 1, we get 1,995.587. For the catchment area 2, we get 47.119. And lastly, for the catchment area 3, we get 193.254. Okay, next is sediment basin. Okay, sediment basin are temporary point with a appropriate control structure used on construction site to capture the erode or disturb soils. The next is sediment basin maintain is similar to sediment trap maintenance. And lastly, the primary purpose of sediment basin is to prevent sediment from entering stream, river, lakes, or wetlands. Okay, from the sediment basin design calculation, we get surface area basin required is equal to 2,366.84 meters square. And for the total basin volume required, we get 2,846.2 meters cube. And for the settling zone, we get is 1,423.1 meters cube, which is larger than 1,199.68 meters cube, and which means the design is okay. Okay, for the checking settlement zone dimension, equal to 49.333, which is larger, which is smaller than 200, which means okay. And for the L1 per W1 ratio, we get 6.588, which is larger than 2, which means is okay. Okay, for the next is by using trial and error to find Y2. Y2, we get 0.3 meter, and for the V2, we get 1,428.1 meter cube, which is larger than 719.81 meter cube, which means the design is okay. From this calculation that we conclude, the spillway for the sediment basin must be designed for 10 years ERI, and the proposed spillway dimension is 1.5 meter, and the width is 0.3 meter height, and the spill level must be set as a minimum 300 above the basin top water level. Okay, next we continue to determine of Q time. The ERR location that we choose is Johor Silica, and the ERR time equal to 10 years, and we get Q10 equal to 2.384 meter cube per second. Okay, we determine the Q riser equal to 0.727 meter cube per second. For the sizing of spillway, Q required that we get is 1.656 meter cube per second. And next, for the Q spillway equal to 2.051 meter cube per second, which is larger than 1.656 meter cube per second, which means our design is okay. Okay, for this calculation, we can conclude it would require 2 events of the same magnitude to fill up the sediment storage zone. Assuming the design is equivalent to 3 months ERR, the storage zone is likely to be filled up in 0.25 years. Okay, lastly for this chapter, erosion control BMPs that we use is silt fence and rock check dams. Okay, next is sediment control BMPs that we use is mulching and geotextile